How to plan power for your build, residential. So I'm going to go through, get yourself a big plan. I've got mine here all filled out. We're going to show you how to get to this point where you actually have all of your points and your circuits mapped out with your load measured. So first thing is just placing your points on your plan. So the way you draw a double power point is like that. Gives you an idea that you've got 2 points there, so you need to calculate for both load. If you're going to do a single, it's just a circle. So let's start with bedrooms. I like to put a double power point either side of the bed. And then also, if it's a big enough bedroom, you might have a wall hung TV or a uplight off into the corner. It's a good idea to have another power point somewhere else in that room. So let's just replicate that across the different rooms that we've got here. Okay, great. So we've got 2 power points either side of the bed for our 3 bedrooms, and we've got another point where a TV will go. We'll move on from there. Let's go to your lounge room. Probably going to want a power point where your television's going to go, and then either side of your couch. Once again, that could be for lights, could be for charging stations. That's a fairly easy one. And even if on the other side of your TV, it's not such a bad idea to have a few points in your lounge room. Next is your hall. Now, your hall, you could have one near the front door. Maybe that's where you hang your coats at the end of the day, or you want a little night light off in the hall for the kids, something like that. Another one is a point to plug in your vacuum. Try and think about those locations that are going to make sense. For me, I've got one here at the end of the hall, one at the very start. That's probably going to be my point for the vacuum. Now, I'm lucky enough to have a study in this house as well. So with a little desk, it's going to put power point above and below the desk. And I normally just double them up to show me that I've got different heights of my points. And that's these points here. Now then we can go into our bathrooms. Now the Australian standard, we've got really specific locations. So when you've got a water container under 40 litres, you've got 150 mil from the container is where you're allowed to put that power point. And then if you've got a big bath, you've got to be half a metre away from that. And there's further regulations for, locations from the shower. There's zones. Check your AS3000. I'm referencing the 2018 guidelines there. So where my vanity is here, I'll have it to the side of my mirror. So for my bathroom, I'm going to put 1 point there inside the bathroom as well. Now then we get off into laundry. I'm going to have a power point ready for my washer and dryer. I'm also going to have a point for where I might have a hanging vacuum. That's another good point. In your pantry, we've got actually a big pantry section where we can walk in. It's like a butler's kitchen. So I'm going to have a couple of bench power points there as well. And then in the kitchen, don't really do your kitchen designer power on this whole lot. Grab yourself your actual plan of the kitchen itself from your kitchen designer, and then start mapping out on top of your benches whereabouts you're going to have those power points as well. You also want to mark where you're going to have your oven, your fridge, all those items. So now that you've got all the different power points mapped out on a plan, you need to start planning your load and your circuits on where they're going to go. So there is some guidance on how many power points you can put per circuit. Now I'm using 2.5 mil cable, and with that cable I'm going to be putting a 20 amp breaker on that one. So the guidance is 1 amp, and so therefore I can put 20 points. Now don't get tricked into thinking that it's 20 of these double power points. No, it's 10 of them as a guidance. Now, but you've got to pay real attention to what you're actually putting in those power points. So in a kitchen, you're not going to load up all of your top benches plus the power point for the dishwasher. That's just not something that you're going to do because your load's going to go much higher. You've got to think about what you're plugging into these power points. And the way that you work out that load is take your watts that you're going to draw. So say you're going to draw 480 watts. You divide that by volts, so 240 volts. Therefore, you get 2 amps on that. So when you're talking about a 20 amp breaker, then therefore I could put 10 of those appliances and I would be hitting that maximum load. So when you look at things like a toaster or an oven, a fridge, you've got to go check what the draw is of those items, and don't load up your circuit beyond what it can actually achieve. So you also don't want to go to the maximum. Have a think about, it's actually a really good idea if you've got appliances plugged in around the house and you need to do fault isolation, and one of those appliances are faulty, keeps tripping the breaker. If it's only tripping the breaker in bedroom 1, then it's great. You know the fault is isolated to just bedroom 1. So don't try and load up your circuits. Have more circuits, have a little bit of a bigger board, more breakers. It's going to make your life easier when you've got faults and you need to find them. So when I come to that here, I'll probably have 2, 4, 6, 8, 10. So that'd load the whole circuit up. So I might here take 2, 4, 6, oh sorry. That would be half if I was doing 10 amp. I'm doing 20 amps, so I can actually do 2, 4, 6, 8, 10, 12, 14, 16. I could actually do this whole section of the house. I just realized I forgot my PowerPoint on my vanity here. 1, 2, 3, 4, 5, 6, 7, 8, 9 in total. 9 doubles, 18 points. I could load all of those up together. What I might do is just have my bedroom, this point, this point, this point, and probably my study, and that's just going to be circuit 1. I might then load up my 2 bathrooms just as circuit 2. So that's nice and easy to understand. I'll then combine probably these 2 bedrooms, put that as circuit 3, separate my lounge off as a circuit by itself, circuit 4, and then I'm left with laundry. Now laundries, here's an example. Because we know what's going to be plugged into the laundry, we're talking about a washing machine and a dryer. That's going to draw a lot of load on its own. So I'm just going to have 1 circuit just for the laundry alone. I'm not going to put anything else on that. And then I might link up my pantry and the other power point for the charger. So here we go, circuit 5, circuit 6. And then when we get into our kitchen, this is where we're going to have, it's a good idea just have a separate circuit altogether for your fridge. For your cooktop, you might actually need, in the cooktop I've got there, I'm going to need 2 2.5mm cables just for the cooktop. We're going to need another one for the oven. And we're also going to be putting a circuit just for the island bench, and another circuit for the power points that go along the top of the bench. Now the reason why we've got so many circuits here is because all of those cooking appliances draw a lot of power, and you've got to go and look at the manufacturer's instructions, do the calculation of how many watts it draws, divide it by volts to get amps, and see how it's loading on your circuit. And make a choice. You're using 16 amp breakers, 20 amp breakers, they're all good things to consider. So this here gives you an idea how to plan out your power circuits. Didn't take all that long, and if you think about the rules of just, it's better to have more breakers, more circuits. It's going to be easier for fault isolation in the future. You're going to be okay. Now let's go and have a look at this in action. Come, I'll take it to the subboard. Now, instead of having all of the cabling going to your main board, sometimes it's a good idea to have a subboard. Your subboard means all of my cabling only needs to go from its location here to the kitchen where most of my circuits are. So I've got a subboard here, and I'll give you an example here of the pantry. So here I've got labeled pantry. This cable goes up into the ceiling. works its way through the ceiling, down the wall, gets to this point here, goes back up to the ceiling, over to another power point on the floor here, and then back up the ceiling, down and into this point for the butler's pantry. Now you always want to go all the way down and all the way back up instead of going through walls. The reason why is if you're going through each of these walls, the Gyprock studs needs to go over the top. Screw could go into the cable there as well. So it's nice and easy when the sheets are on the wall, but you know that your cables are always going vertically up into the ceiling. And if you're lucky enough to be able to get your head into the ceiling, you can see how the cables are wired then. You always want to strap these cables to the wall, keep them nice secure, and use more cable. So yes, you might think you want to put a joint in the roof, but the time and effort to go and put a joint in there, it's a place where a fault can actually happen. Use more cable. Yes, it goes all the way across the room, down, all the way back up, all the way to your next point, but that's one nice solid connection that's unbroken. Don't try and put joints everywhere through the cable. That's just going to cause issues later on when you bury those joints. All right, that gives you a little bit of idea of how to plan out your cabling and gave you a little sneak peek on how to run those. See me next time on how to plan your lighting.